Mr. T here with another calculus tutorial. Today we're going to be talking about something called the product rule. This past week we learned some basic derivative rules and some rewriting skills for finding derivatives of functions. And the function that's shown here on our example, we could solve using our basic derivative rules by foiling this out and then applying the derivative rules. But there is a rule for handling the product of two subfunctions called the product rule. So let's put the product rule over here. So if our original function is made up of two functions multiplied together, let's call them u and v, then when we take the derivative of f of x, we take the product of our first function times the derivative of the second plus the derivative of our first function times the second function. So let's apply this over here. So in our example, this expression is our u of x, and this expression is our v of x. So let's find dy dx applying our new rule over here. So we take our first function and multiply it times the derivative of the second. The derivative of a constant is 0, and the derivative of 4x is 4. Now we add the derivative of the first function, which is going to be 3 minus 4x times the second function. Now we're still having to use FOIL here, so it didn't completely eliminate the need for FOIL, but on some more complicated problems using the product rule would be less complicated than starting out with the FOIL. So let's expand here. So we're going to distribute the 4. And now we have to FOIL these things so that we can combine like terms. So we have 15, and we have plus 12x, and minus 20x, and minus 16x squared. Now we combine our like terms. So for our constants we have 15. For the x's, we have 12x plus 12x is 24x, minus 20x is negative 4x, and we have x squareds here, so we have negative 24x squared. And that would be our final answer. Okay, in our second example here, we will be doing another problem. And I'm going to follow the same rule, but I'm going to show you how to set up the problem in a pattern so that you don't really need to remember the formula. So we are going to pick our first part of our expression, and I'm going to rewrite this here to use a negative exponent. And our second part, and below them we are going to find the derivative of each part. And if we cross multiply on this rectangle here we end up with our derivative rule, because we end up with u times v prime and u prime times v. So we just cross multiply. So I've got x to the minus 1 plus 1 times 1 plus, in this direction, negative x to the minus 2 times x minus 1. After cross multiplying, I'm going to distribute. So now I have x to the minus 1 plus 1, and now I distribute here. Negative x to the minus 2 times x here. We add the exponents, so I end up with negative x to the minus 1. And we end here with positive, because we have negative times negative x to the minus 2. These cancel. So I am left with x to the minus 2 plus 1. I'll GCF factor out this so that I can get a common denominator and get rid of my negative exponent. So I'm going to GCF factor out a x to the negative 2, and I'm left with 1 plus x squared. And I can simplify that by, I'm going to rearrange what's in the leftovers here into traditional order and move this to our denominator to get rid of the negative exponent. And now I have my final answer in factored form. So hopefully this technique of picking the two parts of our original function and setting them up as two items, and then below them take the derivative of each item, and then you can cross multiply, and that automatically gives you the product rule. Have a great day.